Hello there, and welcome to the Sleepless Scientist, a quiet place in the cosmos where your thoughts can unwind and knowledge becomes a soft lullaby for the night. Tonight's journey will take us into a question that has lingered in alleyways, old train stations, forgotten photographs, and even in the equations of modern physics. Are time slips and mysterious time travelers real? Or are they reflections of something deeper? Our struggle to understand the flow of time itself. But before you settle in and get cozy, I'd love if you could take a moment to like this video and subscribe, only if you truly find these quiet explorations enjoyable. And when you're ready, leave a comment to let me know where in the world you're listening from and what time it is for you right now. It's always such a joy to see all the places we gather from, each in our own little slice of time. Now feel free to dim the lights, maybe turn on a fan for a soft background hum, and let's gently begin our journey into the strange and subtle mystery of time slips together. And if your mind begins to wander, that's perfectly fine. Let it drift. We'll still be here, quietly unfolding the story. Time is such a familiar companion. It ticks softly in the background of your day. It moves you from morning coffee to afternoon sunlight to the quiet of night. And yet, every so often, someone claims that time did something unusual, that it hesitated, or folded, or thinned, that for a moment the present was replaced by another century. These experiences are often called time slips, brief shifts in reality, where someone insists they stepped, not metaphorically, but physically, into another era. A Victorian street where there should be traffic lights. Roman soldiers marching where a basement wall once stood. A shop that existed decades ago, fully stocked and brightly lit, only to vanish the next day as if it had never been there. Most of these stories begin the same way, with something subtle, a heaviness in the air, a strange quiet, a feeling that something isn't quite aligned, and tonight we'll begin there. Imagine you're walking down a street you've walked 100 times before, the same cracked pavement, the same bakery window reflecting late afternoon light, the same distant hum of cars moving through traffic. There's comfort in repetition. Your mind barely pays attention. It knows this place. But then, something shifts. Not dramatically, not like a lightning strike, more like the faintest pressure in the air, as though the atmosphere itself has grown heavier. You pause, though you're not sure why. The sounds around you seem muffled, like cotton pressed gently against your ears. You keep walking. The pavement beneath your shoes feels different, harder, uneven. You glance down. Cobblestones. You look up again, expecting to see the familiar storefronts. Instead, the glass windows are gone. Wooden frames, gas lamps, a carriage rolling past where moments ago there had been a taxi. The air smells faintly of coal smoke. People hurry by, dressed in clothing that seems too deliberate to be modern. Long coats, hats, dresses that brush the ground. A man glances at you, not with surprise, but with suspicion, as though you are the one out of place, and then, just as quietly as it began, it ends. The street returns, asphalt, traffic, the smell of gasoline instead of soot. Your phone vibrates in your pocket. Only seconds have passed. This is how many time slip accounts are described, not as wild cinematic adventures, not as glowing portals or spinning tunnels, but as subtle displacements, a gentle misalignment in reality, like two transparent images briefly overlapping. There are common threads woven through these stories. First, the sensation. Many people report dizziness, a tightening in the chest, a strange stillness as though the air has stopped moving. Some describe the world as looking flat or faded, like an old photograph whose colours have softened with age. Second, the environment changes while the location remains the same. The street doesn't move. The geography is constant, but the details, buildings, vehicles, clothing, shift backward in time. Third, the experience is temporary. It lasts seconds, sometimes minutes, rarely longer, and when it ends abruptly. Like waking from a dream, except the person insists they were fully awake. And finally, there is almost never physical evidence. No object brought back, no measurable trace, only memory. One of the most frequently cited locations for such events is a street in Liverpool known as Bold Street. Over decades, individuals have described stepping briefly into scenes from the 1950s or 60s, shop signs reverting to old names, vintage buses passing, radios playing songs not yet recorded in their present moment. What's striking is not the dramatic flair of these accounts, but their structure. They follow a pattern, normalcy, subtle sensory distortion, environmental shift, return, like a wave rising and falling. Another case often discussed involves Roman soldiers reportedly seen marching through the basement of a building in York, England. The witness described their lower legs as partially obscured, as though they were walking on a surface slightly below the modern floor. Years later, archaeologists discovered that a Roman road had indeed run beneath that building, several inches below ground level. Does that prove a rupture in time? Not necessarily. But it adds a quiet complexity to the story, a small detail that refuses to disappear. Before we decide what these events are, it helps to sit gently with what they feel like. To understand that they are not usually theatrical. They are intimate, subtle, personal. It is easy to dismiss such stories outright, and perhaps many of them can be explained through memory distortion, suggestion, or stress. But even then, something interesting remains. Why does the mind choose the past? Why not random chaos? Why not surreal shapes or abstract colours? Why gas lamps and horse-drawn carriages? Why Roman armour instead of something entirely invented? Time slips, whether literal or psychological, seem to reach backward into history, into something recognisable, something structured, as though the past is not gone but layered, like pages in a book pressed tightly together. Most of the time, you see only the page you're on. But perhaps under rare conditions, the edges of another page become visible for just a moment. And if that image lingers long enough, you begin to wonder whether time is not a straight line at all, but something softer, something more dimensional, a fabric perhaps, or a landscape. And before we reach for physics or neuroscience, it helps to notice something simple. Every one of these stories begins with the feeling that the present moment is fragile, that it could, under the right pressure, give way, and that thought alone is enough to keep us quietly listening. The deeper explanations, whether rooted in the brain, in the mathematics of space-time, or in our longing to step outside mortality, will unfold in their own rhythm. For now, it is enough to stand on that familiar street and consider the possibility that the ground beneath your feet may not be as fixed as it feels. Because time, as ordinary as it seems, has a way of surprising even the most confident clocks. And sometimes, the most mysterious part is not whether someone travelled through time, but why the experience feels so real when they say they did. Now, let's gently gather the threads of these recurring experiences and look at their shape more closely. That shape may tell us more than the stories themselves. If you gather time slip accounts from different cities, different decades, even different cultures, something curious begins to emerge. The details change, the clothing styles shift, the vehicles evolve from carriages to trams to mid-century buses. But the structure of the experience remains strangely consistent. It often begins in complete normalcy. A person is shopping, walking home from work, waiting for a train, browsing a bookstore. There is no ritual, no dramatic setup. No sense of summoning the extraordinary, just an ordinary moment moving quietly forward. Then comes the first signal. It is rarely visual. It is felt. A sudden heaviness in the air, a tightening in the chest, a wave of dizziness. Some describe it as stepping into a pocket of silence, as though the world has taken a breath and not yet released it. Others say the colours seem muted, as if someone gently lowered the brightness of the day, and then the shift. The street remains where it is. The geography does not change. But the details rearrange themselves into another era. Shop signs revert to names long retired. Neon lights vanish, replaced by painted wooden boards. Cars become boxier, older, sometimes replaced entirely by horses or early buses. The people move with purpose, unaware of the observer's confusion. They are not ghosts. They do not shimmer or flicker. They appear solid, embodied, entirely at home in their time. In Liverpool, several individuals described stepping briefly into scenes from the 1950s. One man reported walking toward a familiar bookstore only to find, in its place, a clothing shop that historical records later confirmed had indeed occupied that location decades earlier. A young woman described entering a baby goods store that had closed years before she was born. She handled the items, she spoke to staff. When she returned the next day, the building was once again a bank. Whether these accounts are literal or psychological, what stands out is the pattern. The mind does not invent chaos. It invents continuity. It invents coherent worlds. After the environmental shift, there is often interaction, a brief exchange, directions asked, a purchase attempted, a glance exchanged with someone dressed in clothing from another decade, and then, just as suddenly, the return. No gradual fading, no dramatic collapse. The world snaps back into alignment. Traffic resumes. Phones regain signal. The smell of coal smoke gives way to gasoline and asphalt. And almost always, there is no physical evidence, no artifact carried forward, no photograph taken, only the memory. This pattern appears so frequently that it invites a quiet question. If something truly physical were happening, would it be so narratively symmetrical? The shape of the story feels almost too complete. Beginning, distortion, immersion, resolution, like a short film. This does not mean the experiences are fabricated, but it suggests that whatever is occurring, whether external or internal, follows a recognizable arc. There is another common thread. Time slips almost always move backward. People rarely report stepping into a far future city with architecture unknown. To them, they step into eras they recognize, the Victorian period, the Second World War, the 1950s, ancient Rome. Why is that? If time were tearing randomly, we might expect glimpses of unimaginable futures. Instead, the visions are anchored in history, in eras already embedded in cultural memory. The mind seems to reach for something structured and familiar. This brings us to an important distinction. There are two kinds of time travel often discussed in physics. One involves travelling forward, and it is not as impossible as it sounds. According to the theory of relativity, time does not tick at exactly the same rate for everyone. Clocks in orbit around Earth run slightly differently than clocks on the surface. Astronauts on the International Space Station age a tiny fraction of a second less than we do over the course of months. The difference is extremely small but measurable. Time stretches and compresses depending on speed and gravity. If you were to travel extremely fast, approaching the speed of light, time for you would slow compared to those who remained still. If you could somehow move at nearly the speed light itself moves through space, what feels like a few years to you might correspond to decades passing on Earth. There is no need to present the equation to understand the principle. The faster something moves, the slower its clock ticks relative to others, and the stronger the gravitational field, the more gently time flows near it. This is not science fiction. It has been confirmed through precise measurements using atomic clocks, but notice something important. This kind of time travel only moves forward. You return to find others older. You do not revisit the past. Time slips, as described in stories, move backward, and backward travel presents deeper complications. If someone were to step into the past physically, they would not only displace themselves in time, but risk interfering with the sequence of events that led to their own existence. This is where physics grows cautious, yet the stories persist, and when you step back from any single account and instead examine their shared structure, they begin to look less like tears in space-time and more like variations on a theme. The theme of displacement, the feeling of being out of phase. In many accounts, the individual does not feel like an explorer discovering a new world. They feel misplaced, as though they have slipped slightly between layers of something already there. It is almost as if time were not a single flowing river, but multiple currents running side by side. Most of the time you remain in your own current, but occasionally, perhaps through some internal or environmental trigger, your perception brushes against another. Whether that other current is external reality or a construction of the mind is a question we will approach gently. There is no need to rush toward a conclusion. For now, it is enough to observe that the pattern itself tells a story not just about time, but about how humans experience it. Because perhaps the most revealing part of a time slip is not what people see, but how consistently they see it. And when patterns repeat across decades and across continents, it becomes worth asking not only whether time can fracture, but whether the human mind carries its own quiet architecture for doing so. There is a reason these stories feel compelling. Their structure resonates with something internal, and that resonance may be the first real clue. There is one story that lingers differently than the others. Most time-slip accounts dissolve under scrutiny. Details shift, sources trace back to retellings, memories grow more elaborate with repetition. But occasionally a case survives longer than expected, not because it proves anything, but because it refuses to fade neatly away. In the early 1950s, a young man working in a basement in York, England, reported something deeply unsettling. He was alone, chiseling into a stone wall beneath a historic building. The work was repetitive, predictable, the sort of task that allows the mind to drift. Then he heard a sound, not the echo of tools, not the settling of stone, a horn, faint at first, distant, as though it were travelling through layers of earth. He paused, listening more closely. The sound grew clearer, rhythmic, intentional. And then through the wall in front of him, a group of Roman soldiers appeared. They were not transparent, not glowing. They looked solid and embodied, marching in formation. They wore tunics, carried shields, some led horses. The witness later described them as weary, as though returning from campaign. But one detail stood out. Their lower legs were not fully visible. It was as if they were walking on a surface slightly below the modern basement floor. The procession moved steadily across the space, and then, without ceremony, vanished. The man did not tell the story publicly for many years. When he eventually did, skeptics pointed out inaccuracies. Roman soldiers, they said, didn't carry round shields. They used rectangular ones. The uniforms were described as the wrong colour, and so the story joined the quiet pile of curious but unreliable accounts. Until decades later, when archaeologists excavating beneath that very building discovered something unexpected. A Roman road, not imagined, not metaphorical, a physical road buried several inches below the current basement level. The elevation matched the witness's description. If someone had been standing on that ancient road, their feet would indeed have appeared lower than the modern floor. Further research also revealed that certain Roman auxiliary units, composed of non-citizen soldiers, did in fact use round shields and wore tunics in colours previously thought inaccurate. The alignment was not perfect proof of anything, but it complicated the dismissal. It introduced a tension. Was it coincidence? Could the witness have subconsciously absorbed historical knowledge before archaeology confirmed it? Or was it an unusually vivid hallucination that happened to align with buried history? Notice how quickly the mind wants to choose: proof or delusion, time travel or imagination. But perhaps the more interesting space is the one between those extremes. Consider this gently. If you were to stand in a place layered with centuries of history, what would it mean for your mind to momentarily access that depth? Not physically travel, not displace atoms backward through time, but perceive something embedded in the location. Human environments are not blank surfaces. They accumulate structure, architecture, and meaning. Cities are built on top of themselves. Streets are repaved. Foundations are reinforced. But the geometry of what once stood often remains beneath. The idea that a place holds memory is poetic, not scientific. Stones do not record events in the way brains do, and yet, as a metaphor, it is powerful. When the witness described soldiers marching through the basement, he was not describing a fantasy landscape. He described a historically accurate military presence that once occupied that exact ground. If we approach this through physics, we must tread carefully. Modern physics does not support the idea of echoes from the past replaying themselves in space like recorded projections. Time, according to our best current models, does not leave behind looping images like an old film reel. But physics does tell us something else. It tells us that time is woven into space. In Einstein's understanding of the universe, space and time are not separate entities. They form a single fabric, often called space-time. Massive objects like planets and stars curve this fabric, and everything within it moves along that curvature. We can picture this gently. Imagine a stretched sheet. Place a heavy ball in the center. The sheet dips. Smaller objects rolling nearby follow curved paths. Around it, in a similar way, mass shapes the structure of space-time. Now, this curvature does not create ghosts of Roman soldiers. It does not replay ancient battles, but it reminds us that the past is not simply erased. It is part of the structure of the universe. In some interpretations of modern cosmology, all moments exist within the four-dimensional structure of space-time. Past, present, and future are not flowing away into nothingness. They are coordinates. We experience them sequentially. But that does not necessarily mean they vanish. This does not confirm the York sighting as a literal slip through centuries, but it invites a softer possibility. Perhaps what feels like a rupture in time is sometimes a rupture in perception. The human brain is extraordinarily sensitive to pattern. It fills gaps. It reconstructs scenes. It predicts what should be there. Under certain conditions, especially in environments rich with historical context, perception may become unusually vivid. When the witness heard the horn, perhaps his mind reached for the most plausible historical explanation embedded in that location. Or perhaps something more subtle occurred. There is a humility required here. Science demands evidence. And in this case, we do not have repeatable experiments or physical artifacts carried across centuries. We have a story, a delayed retelling, and an archaeological discovery that aligned with certain details. But alignment is not proof. It is intrigue. And intrigue is enough to keep the question open. Because when memory and buried history intersect, even imperfectly, it challenges the idea that time is a simple, straight corridor we walk through once and leave behind. It suggests instead that our present stands on invisible scaffolding of everything that came before, and perhaps, under rare and unusual circumstances, that scaffolding becomes briefly visible, not because time has broken, but because our awareness has shifted. The Roman soldiers of York may never march again. The basement remains quiet. The road lies undisturbed beneath modern flooring, yet the story persists, not as confirmation of time travel, but as a reminder that history is closer than we think, sometimes only inches below our feet, and sometimes, perhaps, only a flicker away from being seen. There are cities that seem to collect stories the way old houses collect dust. Liverpool has Bold Street, York has its Roman layers, Versailles has its gardens where two visitors once believed they stepped into the 18th century. Even small towns sometimes carry a reputation for thin places, as though the boundary between eras there is somehow more fragile. It is tempting to imagine that certain streets hold cracks in time, that under the right conditions the fabric of reality loosens, allowing another century to show through like wallpaper peeling at the edges. But before we step too quickly into that image, it helps to ask a quieter question. Why do stories cluster? If time slips were random physical events, one might expect them to appear evenly across geography. A parking lot in one city, a desert in another, a forest clearing with no particular history. Yet most reported cases occur in locations saturated with cultural memory. Old cities, historic districts, places layered with architecture from multiple eras. This pattern alone is revealing. Human perception does not operate in a vacuum. It is guided by context. When you walk through a modern suburb, your expectations are anchored firmly in the present. But when you walk through a city whose streets were laid centuries ago, your mind already holds multiple timelines at once. You know, even without looking, that beneath the pavement lie older foundations, that the cafe you pass may once have been a stable, that the building beside it may conceal beams carved long before electricity existed. In such environments, imagination does not need to stretch far, it simply follows the lines already there. There are also environmental theories, often discussed in more speculative circles, that attempt to explain geographic clustering through physical forces. Some suggest that underground electrical currents, natural flows of energy through the earth, might affect human perception. Others point to subtle electromagnetic fields created by buried infrastructure, metal deposits, or shifting geology. The earth does generate electrical activity. Lightning strikes redistribute charge across the surface of the planet. Solar storms interact with Earth's magnetic field, creating auroras and faint electromagnetic fluctuations. These are measurable phenomena. But there is no reliable scientific evidence that such fields cause people to see historical scenes. That said, the human brain is sensitive to its environment. It responds to light levels, sound frequencies, and even small changes in atmospheric pressure. If you have ever walked into a cathedral and felt suddenly hushed, you have experienced how architecture alone can alter perception. Now imagine standing in a narrow street bordered by centuries-old stone, the air cooler, the sound slightly muffled, the geometry unfamiliar to modern design. Under those conditions, the mind may become unusually attentive. Slight distortions in sound or light might feel amplified. A reflection in a window might briefly resemble something older. And because the location carries history, the interpretation flows naturally in that direction. It is important to understand that perception is predictive. The brain is not passively recording the world like a camera. It is constantly anticipating what it expects to see. It fills gaps. It smooths inconsistencies. It builds a coherent narrative from incomplete input. When context strongly suggests the past, even subtle ambiguity may be resolved in that direction. There is another layer to geographic clustering that is often overlooked. Stories attract stories. Once a location becomes associated with unusual events, more people visit it with heightened expectation. Expectation sharpens attention. Attention increases the likelihood of noticing anomalies. And anomalies, once noticed, are interpreted through the existing narrative. This does not imply dishonesty. It is a natural feature of human cognition. If you're told that a certain corner of a street is haunted, you may find yourself noticing every draft of wind, every flicker of shadow. In a different context, you would ignore these details entirely. In Bold Street, for example, after the first few reports of time slips circulated, later accounts appeared with strikingly similar structures. A brief sense of disorientation, a glimpse of older shop signs, a return to the present. The repetition creates credibility in some minds, but it also creates a template, and templates guide experience. None of this proves that time is immutable and rigid beyond all imagination. Physics itself tells us that time is not as absolute as it once seemed. Under intense gravity, clocks tick more slowly. Near extremely massive objects, time stretches compared to regions farther away. These differences are subtle on Earth, but dramatic near black holes. Yet even in those extreme cases, time does not randomly tear in urban streets. It bends predictably according to the distribution of mass and energy. To create a literal hole in time, a path that leads from one century to another, would require conditions far beyond anything found in historic city centres. The mathematics describing such possibilities involves enormous energies and exotic forms of matter that we have never observed in everyday environments. So when we return to the clustering of time-slip stories, the simplest explanation remains rooted in human experience. Historic locations invite temporal imagination. Layered architecture invites layered perception. Narrative expectation invites narrative fulfillment, and yet there is something deeply human about the idea that time might feel thinner in certain places. When you stand in a medieval alleyway, you may feel as though the past is pressing gently against the present, not because it is physically bleeding through, but because the distance between eras feels emotionally shorter. In modern glass towers, history feels distant. In ancient streets, it feels immediate. Perhaps what people describe as a time slip is not a crack in physics, but an intensified awareness of continuity. A moment when the layers of a city become so vivid that the boundary between memory and imagination softens. The ground beneath your feet has carried countless lives, countless footsteps, countless moments of fear, hope, commerce, celebration. It is not unreasonable that the mind, standing in such a place, might briefly sense that depth, not as literal transportation, but as proximity. Cities do not make time thin, but they remind us how thick time truly is, and sometimes, when you become aware of that thickness, of all the centuries compressed beneath your daily routine, it can feel almost like slipping, not into the past, but into a deeper understanding that the present rests on something vast, and that realization alone can make an ordinary street feel quietly extraordinary. When someone describes stepping into another century, we instinctively imagine a camera malfunction, as though reality briefly swapped tapes and played the wrong reel. But the mind does not operate like a camera. It does not store moments as complete, unchanging files that can be replayed exactly as they were. Instead, memory is more like a painting that is retouched each time it is viewed. You remember walking into a room, but you do not store every shadow, every sound, every detail of texture. You store fragments, impressions, emotional tones. Later, when you recall that room, your brain reconstructs it from those fragments. It fills the gaps with what seems most plausible. This process is not a flaw. It is efficient. If the brain recorded every sensory detail in perfect fidelity, it would be overwhelmed. Instead, it preserves meaning rather than precision. Psychologists have demonstrated this gently but convincingly. When groups of people witness the same event, a staged accident for example, their recollections diverge in subtle but measurable ways. The wording of questions alone can alter what they remember. Ask whether two cars collided, and the memory remains moderate. Ask whether they smashed, and people later report broken glass that was never there. The brain integrates suggestions seamlessly into reconstruction. Now consider how this applies to time-slip stories. Take the well-known Versailles account from the early 20th century. Two women walking through the gardens believed they had glimpsed scenes from the 18th century. They later wrote detailed descriptions of clothing, architecture, and behaviour, but over time, as their account was revised and republished, details shifted. Some elements grew sharper, others softened. Certain descriptions aligned more closely with historical records after further research. This does not imply deliberate fabrication. It illustrates how memory evolves. Each retelling strengthens certain threads and allows others to fade. When someone experiences a moment of confusion, perhaps due to heat, fatigue, or emotional intensity, the mind seeks coherence. It assembles the most plausible explanation available within its cultural framework. In a city rich with history, that explanation may draw from the past. There is also something called confabulation, a word that sounds harsh but simply refers to the brain's ability to generate narrative continuity when pieces are missing. It is not lying, it is stitching. If a person feels sudden dizziness and later notices an architectural detail that looks old-fashioned, their mind may bind these perceptions together into a single story. And once a story is formed, it gains stability. The more it is told, the more emotionally reinforced it becomes. Neuroscience suggests that each time you recall a memory, it becomes temporarily flexible again before being stored once more. During that brief window, new details, subtle suggestions, images encountered later, conversations with others, can become integrated. Imagine memory as soft clay. Each time you lift it, it reshapes slightly before hardening again. Over years, this reshaping can be profound. This helps explain why some time-slip accounts appear to grow more intricate with time. The first telling may be simple, a strange feeling, a glimpse of something old-fashioned. But later versions include precise clothing colours, specific shop names, vivid emotional exchanges. Memory is not deteriorating in these cases, it is elaborating. This does not mean that every unusual perception is purely imagined. It means that the boundary between perception and interpretation is porous. The brain is constantly predicting what it expects to perceive next. If reality delivers ambiguous input, an unfamiliar sound, a distorted reflection, a sudden silence, the brain resolves that ambiguity using its internal library of possibilities. In environments steeped in history, the past becomes one of those possibilities. There is also the phenomenon of déjà vu, a fleeting sense that a present moment has already occurred. Neuroscientists believe this may arise when the brain systems for familiarity and recall briefly activate out of sync. You feel recognition without context. For a few seconds, the present feels layered. Imagine how such a sensation, occurring in a historic street, could be interpreted as temporal displacement. Add emotion, surprise, fear, awe, and the experience becomes deeply encoded. Years later, it remains vivid. We must be careful here not to reduce human experience to mere error. The brain's predictive and reconstructive nature is not a weakness. It is what allows you to navigate the world fluidly. It is what lets you anticipate traffic while driving, complete sentences mid-conversation, and recognize faces in a crowd. but that same capacity for pattern making can create powerful illusions under certain conditions. Time slips, when examined through this lens, begin to look less like tears in space-time and more like moments when perception and expectation briefly misalign. A subtle shift in sensory input, a rapid search for coherence, a narrative formed from fragments, and once formed, that narrative becomes part of identity. It is important to remember that people who report these experiences often describe them with sincerity. They do not speak as though recounting fiction. They speak as though describing something that felt unquestionably real. And in a meaningful sense, it was real. The emotions were real. The confusion was real. The sense of displacement was real. The interpretation may be debatable, but the experience itself deserves respect. As we move forward, it becomes clear that understanding time slips requires more than examining streets and buildings. It requires understanding how the mind constructs reality moment by moment. Because before we ask whether time can fracture, we must understand how easily perception can bend. And sometimes, the bending of perception is enough to create a world that feels entirely authentic, even if it lasts only a few seconds. There is a quiet argument often offered in defense of time slips. If two people see the same thing, it must be real. It sounds reasonable. If one person glimpses Roman soldiers in a basement, perhaps that is imagination. But if two companions walking through a garden both report seeing figures dressed in clothing from another century, then surely something external must have occurred. Shared experience carries weight, and yet human perception is rarely isolated, it is shaped. It is continuously by subtle social cues, a raised eyebrow, a whispered comment, a shift in posture. Imagine walking beside a friend through a large historic estate. The afternoon is warm, the air feels heavy. Your companion suddenly slows and says quietly, "Do you feel that?" You pause. The question alone changes your perception. You become alert. You scan your surroundings for irregularity. "Something feels strange," your friend adds. In that moment, ambiguity becomes meaningful. If a costume performer appears in the distance, perhaps part of a reenactment, perhaps simply dressed unusually, your mind is primed to interpret the sight as extraordinary. Later, when recalling the experience, the details may align even more closely. You both felt the stillness. You both noticed the unusual clothing. You both agreed that something was not quite right. Agreement strengthens memory. But agreement does not necessarily confirm the nature of the event. Psychologists call this memory conformity. When individuals discuss an event, their recollections often begin to converge, not because they are consciously altering their stories, but because hearing another version subtly reshapes their own. If one person remembers a blue coat and another remembers a grey one, repeated conversation may result in both recalling it as blue-grey, a blended compromise that feels solid and certain. In time slip accounts involving multiple witnesses, this dynamic is frequently present. Initial descriptions may differ slightly, but over time, a shared narrative emerges, polished, consistent, emotionally reinforced. It is also important to consider emotional contagion. Humans are highly sensitive to one another's fear, excitement, and surprise. If one person reacts strongly to an ambiguous stimulus, others nearby often experience a corresponding surge of emotion. Emotion sharpens perception. Under emotional intensity, time itself can feel distorted, seconds stretch, details appear sharper than they truly were. Have you ever narrowly avoided a car accident? Many people report that in such moments time seems to slow dramatically. The physics of the universe has not changed. The clock continues at its steady rate, but your perception accelerates. processing information rapidly and creating the illusion of expanded time. Now imagine that heightened awareness occurring in a historically charged location, a sudden stillness, a companion's anxious whisper, an unusual visual cue. The ingredients are present for a powerful shared interpretation. None of this dismisses the sincerity of witnesses. Shared experiences feel convincing precisely because they are shared. Social reinforcement is one of the strongest forms of validation available to us. If you doubt your own senses, but someone beside you confirms them, your uncertainty dissolves. This mechanism has been observed in controlled laboratory settings. When individuals are asked to estimate line lengths or answer simple perceptual questions in a group setting, they often conform to the majority opinion, even when that opinion is clearly incorrect. Not out of dishonesty, but out of a subtle desire for coherence. The mind prefers agreement to isolation. There is also the phenomenon of expectation shaping perception. If two people enter a location already primed by stories, perhaps they have heard rumours of unusual occurrences there, they may unconsciously search for confirming details. Expectation narrows interpretation. Consider how often modern time-slip stories occur in places already known for their history. Rarely does someone walking through a brand new shopping mall report stepping into ancient Rome. The narrative framework is absent. But in a centuries-old garden or beneath a medieval building, the imagination has rich material to draw from. This does not mean that every shared account collapses into suggestion. It means that shared perception is complex, and complexity is often mistaken for mystery. It's also worth remembering that human beings evolved as social creatures. Our survival depended on coordinated interpretation of the environment. If one person saw danger and another did not, discussion resolved the discrepancy. Agreement became safety. Even today, when confronted with ambiguity, we look to those around us for confirmation. In time-slip cases involving multiple witnesses, that ancient mechanism remains active. Two people pause. Both sense something unusual. Both scan their surroundings for explanation. Both settle on a similar interpretation. Over time, their shared story becomes stable. It acquires detail. It resists doubt. And yet, it may still have originated from subtle misalignment in perception, rather than a literal shift in time. This understanding does not rob such stories of wonder. In some ways, it deepens it, because it reveals how exquisitely responsive the human mind is to context, to emotion, to one another. Time slips when experience collectively highlights something profound. We do not encounter reality alone, we construct it together. The present moment is not simply received by each of us in isolation. It is shaped, reinforced, and interpreted through shared language. And if perception can be gently guided in a group, then the sensation of stepping briefly into another era may be less about breaking the laws of physics, and more about the extraordinary flexibility of shared awareness. The past may not have physically returned, but for a moment, two minds aligned in such a way that it felt as though it had, and sometimes that alignment is powerful enough to leave a story echoing for decades. If you have ever waited anxiously for news, you already know that time is not steady. A single minute can feel unbearably long when anticipation fills it, yet an entire afternoon can vanish unnoticed when you're absorbed in conversation. The clock does not change its rhythm, its hands move in the same quiet circles. But your experience of those movements shifts. This difference between measured time and felt time is one of the most ordinary mysteries of human life. The brain does not possess a single ticking mechanism that tracks time like a mechanical watch. Instead, your sense of duration emerges from networks of activity, attention, emotion, memory, prediction, all working together. When something demands intense focus, your brain records more detail. Later, when you look back, that period feels extended because it contains more remembered fragments. In contrast, routine moments compress in memory. Fewer distinct impressions mean the stretch of time feels shorter. This is why childhood summers often seem endless in retrospect. Everything is new. Each day is filled with first experiences. The mind stores a dense collection of impressions. As adulthood settles into repetition, novelty decreases. Weeks pass with fewer distinct markers. Time feels faster, not because it moves differently, but because memory contains fewer anchors. Now imagine a moment of sudden strangeness, a perceived time slip. The environment feels wrong. Your attention heightens. Every sensory detail sharpens. You scan faces, textures, sounds. Even if the event lasts only seconds, your brain records it with unusual intensity. Later, the memory expands. It acquires weight. It resists fading. There's also a subtle phenomenon known as temporal binding. When events occur in rapid succession, the brain may interpret them as causally connected even if they are not. A flash of light and a distant sound may blend into a single narrative. A feeling of dizziness and a glimpse of unfamiliar clothing may fuse into a unified story. The mind seeks coherence. It does not tolerate loose fragments comfortably. It gathers them into patterns. In certain neurological conditions, this pattern making can become even more vivid. Electrical activity in regions associated with memory and familiarity can briefly misfire, creating intense sensations of recognition or unreality. The world may feel dreamlike yet hyper-real at the same time. People who experience such episodes often describe them as profoundly convincing, and yet they originate entirely within the brain's internal signalling. This is not to suggest that all time slip reports stem from neurological disturbance. Rather, it illustrates how easily the sense of reality can shift without any change in external physics. The elasticity of perception is built into us. There is another curious aspect of time that deserves gentle attention. Physics describes time as a dimension, much like the dimensions of space. If you mark a location with 3 coordinates, length, width, height, you can specify where something is. Add a 4th coordinate, time, and you specify when. In this view, past events do not vanish into nothingness. They occupy their own positions within the broader structure of space-time. Some interpretations of modern cosmology suggest that all moments, past, present, future, exist within that structure. We experience them sequentially, but the structure itself may not flow. It may simply be. You can imagine this softly as a film strip. Each frame exists simultaneously along the reel. When projected, they appear to move, but the frames themselves are fixed. If this perspective holds even partially true, then the sensation of layered time may not be entirely metaphorical. The present moment stands within a vast arrangement of coordinates that include everything that has already occurred. But here is the important distinction. Even if time as a dimension is structured, there is no evidence that human consciousness can step backward along that structure at will. The mathematics describing space-time curvature, how mass and energy shape the geometry of the universe, does not allow casual jumps between distant coordinates. In extreme theoretical conditions, under enormous gravitational forces or exotic states of matter, equations suggest unusual possibilities. But those conditions involve energies far beyond anything encountered on a city street. The difference between what is mathematically conceivable and what is physically accessible is profound. So where does that leave the feeling of a time slip? Perhaps it lives in the overlap between psychological elasticity and physical structure. The brain can already stretch, compress, and layer time in experience. It can create moments that feel out of sequence. It can generate recognition without prior exposure. It can amplify seconds into what feels like minutes. Combine that with environments saturated in history, and the result can be remarkably convincing. You feel displaced. You feel as though you have brushed against another era. But the displacement may be internal rather than external. There is something almost comforting in this realization. Time need not break for experience to feel extraordinary. The mind itself is capable of creating profound distortions of duration and continuity. And yet, even after acknowledging this, the question remains: if time is elastic in perception and structured in physics, could there be conditions under which those two realities intersect in unexpected ways? Could extreme gravitational environments, for example, alter the flow of time enough to produce genuine displacement? Astronauts travelling at high speeds age ever so slightly more slowly than those on Earth. The difference is tiny, fractions of a second over months, but it is measurable. Near immensely massive objects such as black holes, time slows dramatically compared to distant observers. If someone could orbit close to such an object and survive, years might pass elsewhere while only hours pass for them. This is not fiction. It is a prediction confirmed through observation of gravitational effects. But notice again, all of these examples move forward in time relative to others. They do not rewind. They do not create sudden returns to ancient streets. Time in physics bends, but it does not casually fold backward in everyday life. So perhaps the most realistic place for time slips to occur is not in space-time itself, but in the flexible architecture of the mind. The mind, after all, is already a kind of time traveller. It moves effortlessly between past and future. It reconstructs childhood. It imagines tomorrow. It simulates possibilities. And occasionally, under the right conditions, it may blend those simulations with perception in ways that feel startlingly real. Time does not need to tear. It only needs to feel thinner, and sometimes that feeling alone is enough to create a story that lasts a lifetime. Until now, we've been moving carefully through perception, through memory, suggestion, shared experience, and the quiet flexibility of the human mind. But there is something important to acknowledge. Time is not only elastic in feeling, it is elastic in reality. For centuries, time was thought to be universal, a great invisible river flowing evenly everywhere. If two clocks were built perfectly and set side by side, they would tick together forever. This was the comfortable assumption. Then, in the early 20th century, a young physicist named Albert Einstein proposed something deeply unsettling. He suggested that time is not absolute. It does not tick at the same rate for everyone. Instead, time depends on motion and gravity. Imagine two identical clocks. One remains on Earth, the other boards a spacecraft travelling at extraordinary speed, so fast that it approaches the speed at which light moves through empty space. When the travelling clock returns, it will not match the one that stayed behind. It will be slightly behind. Time for the moving clock has passed more slowly. There is an equation that describes this precisely, but we do not need to speak it aloud in symbols. The essence is simple. The closer something moves to the speed of light, the more slowly time flows for it compared to something at rest. This effect has been measured repeatedly. Atomic clocks placed on fast-moving aircraft tick differently from identical clocks on the ground. Satellites orbiting Earth must constantly adjust for these differences, or our navigation systems would drift off course. If relativity were ignored, the maps on your phone would slowly become inaccurate. So this is not speculation. Time truly stretches. There is a second aspect to this. Gravity also alters time. If you place one clock at sea level and another high on a mountain, the clock lower down, closer to Earth's mass, ticks slightly more slowly. The difference is tiny but measurable. The stronger the gravitational field, the slower time passes relative to regions where gravity is weaker. Near an object as dense as a black hole, this slowing becomes extreme. To an outside observer, time near the black hole appears to almost freeze. These are not illusions of perception. They are features of space-time itself. So when people speak of time bending, physics does not laugh. It nods. Time bends. But here is the quiet boundary. All confirmed examples of time dilation move forward relative to others. The traveller returns older than before, but younger than those who remained behind. There is no confirmed case of someone moving backward. Relativity allows stretching. It allows uneven ticking. It does not easily allow reversal. To move backward would require space-time to fold in on itself in a very specific way, creating a path that loops through time rather than advancing along it. Some mathematical solutions suggest such paths might exist under extreme theoretical conditions, but these conditions involve immense energies or exotic forms of matter that we have never observed in everyday reality. So when someone steps briefly into what feels like another century while walking down a city street, relativity does not immediately offer support. The bending of time in physics is subtle and continuous. It does not produce sudden swaps of entire environments, and yet the fact that time is not universal changes everything. It means that the present moment is not identical for all observers. It means that simultaneity is relative. Two events that appear simultaneous from one perspective may not be so from another. If you are travelling near the speed of light, the order of distant events could appear rearranged compared to someone standing still. This does not create time slips, but it dissolves the old, rigid idea of time as a single shared now. There is no universal present. Instead, there are overlapping perspectives. This realization alone feels almost like a slip. The comfort of a shared ticking dissolves into something more fluid, and yet, the mathematics governing these effects is exact. It predicts the slowing of time to astonishing precision. It does not predict spontaneous leaps into the past triggered by atmospheric heaviness or emotional intensity. So where does that leave us? Perhaps in a middle space. Time in physics is flexible but disciplined. It bends according to clear principles. It stretches under speed and gravity. It can differ from one observer to another, but it does not behave whimsically. The stories of time slips suggest abrupt displacement. Relativity describes gradual divergence. The two are not identical. And still, there is something quietly profound in knowing that time is not a simple line marching forward uniformly everywhere. The present is not absolute. The future is not identical for all travellers. The universe allows for subtle asymmetry. This does not validate Bold Street or Roman basements as gateways, but it reminds us that the foundation of reality is stranger than intuition once believed. When Einstein replaced the rigid ticking of universal time with a dynamic space-time shaped by motion and gravity, he did not open a portal to medieval streets, but he did open a door to deeper humility. The clock you trust so completely is not immune to context. It bends with the world around it, and if time can stretch under the influence of speed and mass, it invites a gentle wonder. What else might be possible under conditions we do not yet fully understand? We must tread carefully here. Speculation is not evidence, but curiosity is not error. Time bends in reality, just not in the dramatic, cinematic way that stories often suggest. The bending is subtle, mathematical, predictable, and perhaps that quiet predictability is more astonishing than any sudden leap into the past, because it means that even as you sit here, listening, time for you is flowing at a rate slightly different from someone standing at the top of a mountain or orbiting above the atmosphere. The difference is microscopic, but it is real. And sometimes the most extraordinary truths are the ones too small to notice until you look closely. If relativity tells us that time can stretch, the next question arises almost automatically. Can it fold? Imagine holding a sheet of paper in your hands. On the left side you draw a small dot. On the right side another dot. If you trace a line from one to the other, you must travel across the entire surface. Now imagine folding the paper so the two dots touch. The distance between them disappears. In physics, this image is often used to describe a hypothetical structure known as a wormhole. Not a tunnel dug through soil, but a shortcut through the geometry of space-time itself. If space and time are woven together into a single fabric, and if that fabric can bend under the influence of mass and energy, then perhaps it can bend so dramatically that distant points connect. The mathematics that describe gravity, Einstein's field equations, allow such extreme curvature in theory. Under certain exotic solutions, space-time can form a bridge between two distant regions. Some of these theoretical bridges would connect not only different places, but potentially different moments. If one mouth of such a tunnel experienced time differently than the other, perhaps because it moved at high speed or sat near a strong gravitational field, the difference in elapsed time between the two ends could create something resembling a time machine. Again, there are equations that detail this precisely. But in plain language, the idea is simple. If one entrance to the tunnel ages more slowly than the other, stepping through might place you at a moment that does not match your departure. The image is captivating. Fold the page, step across. But here is where reality becomes cautious. To keep such a tunnel open, the equations suggest it would require a form of matter with unusual properties. Matter that behaves in ways we have never observed in stable, macroscopic amounts. It would need to resist collapse under gravity, holding the tunnel's throat open against enormous pressure. Some theoretical physicists describe this as requiring negative energy density, a concept that, while appearing in certain quantum calculations, has never been harnessed in any practical or large-scale way. Without such support, the wormhole would pinch closed almost instantly. So while the mathematics does not forbid these structures outright, it does not offer any clear path to building or stabilizing them. There is also another curious solution within relativity that has intrigued physicists for decades. In certain rotating models of the universe, imagined under highly specific conditions, space-time itself can curve in such a way that paths loop backward. These paths are sometimes described as closed, time-like curves. In plain language, that means a trajectory through space-time that returns to its own past. The idea sounds dramatic, but it arises naturally from the geometry of curved space-time under extreme assumptions. Yet there is a profound difference between a mathematical solution and a physically realized structure. Mathematics allows many possibilities. Nature selects only some. Even if closed loops are permitted by the equations, they may be forbidden by deeper physical laws. Some physicists have suggested that quantum effects, the tiny fluctuations that permeate empty space, would become unstable near any attempt to form a time loop, effectively destroying it before it could function. This idea is sometimes referred to as chronology protection, the suggestion that the universe safeguards its own consistency. Because backward time travel introduces paradox. If you step into the past and alter an event that led to your own existence, what becomes of you? The so-called grandfather paradox is simple to state. If someone were to prevent their own grandparents from meeting, would they erase themselves? Physics does not yet offer a definitive answer to such questions, because we do not yet know whether backward travel is possible at all. Some interpretations propose that events would remain self-consistent, that any attempt to alter the past would already be woven into history. Others suggest that alternative timelines might branch, preserving consistency in different ways. But these remain speculative. What matters here is this: the bending of space-time under gravity is real and measurable. The existence of wormhole-like solutions is mathematically valid under certain assumptions. The possibility of time loops appears in certain theoretical frameworks, and yet none of these phenomena resemble the sudden, localized shifts described in time-slip accounts. If a wormhole existed on a city street, its gravitational signature would be unmistakable. The distortion of light and matter would not go unnoticed. The energy involved would dwarf anything present in everyday environments. Time in physics bends through continuous curvature, not abrupt scene changes. Still, the mere fact that the equations of relativity do not absolutely forbid loops invites humility. The universe has surprised us before. Black holes were once considered mathematical curiosities. Now we observe them directly. Gravitational waves were once theoretical ripples in space-time. Now we measure them passing through Earth. So we must balance skepticism with openness. Time slips as described in folklore, brief transitions into Victorian streets or Roman corridors, do not align with our current understanding of gravitational physics. But the deeper structure of time is more intricate than classical intuition ever imagined. The fabric of space-time can curve, stretch, and warp under extreme conditions. It may not tear casually, but it is not rigid. And perhaps that is enough to keep the question alive, not as a sensational claim, but as a quiet exploration. If time can bend under gravity and speed, then the universe already contains more flexibility than our ancestors suspected. That flexibility does not guarantee passage into the past, but it does remind us that time is not the simple, straight road we once believed it to be. It is a landscape, mostly smooth, occasionally curved, and still largely unexplored. By now, we've wandered through bending clocks and folded pages of space-time. We've seen that time stretches under speed, slows under gravity, and curves under extreme mass. We have also glimpsed the possibility, at least in mathematics, that paths might exist which loop backward. But there is a question that lingers gently in the background. If the equations allow such loops, why do we not see them? Why is the world not filled with visitors from tomorrow? In the 1990s, the physicist Stephen Hawking proposed a simple but powerful idea. He suggested that the universe may have what he called a form of chronology protection. The phrase sounds dramatic, but the meaning is subtle. If the laws of physics allow a scenario that would create contradictions, such as travelling back to alter events in your own past, then perhaps deeper physical processes intervene before that scenario can fully form, not through intention, not through enforcement, but through instability. Imagine again the folded sheet of paper representing a wormhole. To keep that fold open, enormous forces must resist collapse. The structure must remain stable long enough for something to pass through. But according to certain calculations, when you approach conditions that might allow time to loop backward, tiny quantum fluctuations, the restless activity present even in empty space, would begin to grow uncontrollably. Energy would accumulate near the mouth of the tunnel. Radiation would intensify. The structure would destabilize. In other words, the very attempt to create a backward path through time might cause the tunnel to destroy itself. It is not that the universe forbids the idea, it is that the idea may be physically unsustainable. Think of it like this. You can draw a perfectly straight line across a frozen lake. In theory, you can walk along it, but if the ice grows thinner and thinner as you approach the center, eventually the structure fails. Not because someone prevents you from crossing, but because the material cannot support the strain. Chronology protection suggests that time loops may be like thin ice. The The closer you approach them, the more unstable the environment becomes. The universe may quietly close doors before contradictions enter. This idea is not universally accepted, and it is not proven beyond doubt. It is a proposal, an attempt to reconcile the flexibility of space-time with the consistency of cause and effect. Because causality is not merely a philosophical preference. It is woven deeply into the structure of physical law. Events unfold in sequence. Causes precede consequences. Energy transfers from one state to another. Information flows forward. If backward time travel were easily possible, this sequence would become uncertain. You could receive information before it was sent. You could alter events that led to your own actions. The neat unfolding of physical processes would tangle. Nature does tolerate strange phenomena. Quantum particles behave in ways that defy classical intuition. Light behaves as both wave and particle. Space itself expands. But even in these strangenesses, consistency remains. Predictions hold, patterns repeat. The idea that the universe guards its timeline is in some sense a defense of that consistency. It suggests that while space-time can bend, it resists being twisted into knots. There is another reason this proposal feels intuitively appealing. We do not observe paradoxes in everyday life. You have never met an older version of yourself arriving from the future to warn you of an impending mistake. Historical records do not contain verified appearances of travellers bearing knowledge from centuries ahead. The absence of such evidence does not prove impossibility, but it does suggest rarity, and when a phenomenon is theoretically possible yet never observed, physicists begin to suspect hidden constraints. Chronology protection offers one such constraint. It says that even if the mathematics of general relativity permits certain exotic geometries, the quantum structure of reality, the tiny fluctuations that exist everywhere, may intervene to prevent them from becoming stable. It is as though the universe contains its own subtle correction mechanism, not conscious, not purposeful, but stabilizing. And yet, just as this idea seems to close the door firmly on backward travel, quantum physics complicates the picture once again. At the smallest scales, the behavior of particles does not always align neatly with our intuitive sense of sequence. In certain experiments, particles appear to influence one another across distances instantly. In others, the order of events becomes ambiguous when measured from different perspectives. These effects do not permit practical time travel. They do not allow you to send messages into your own past, but they blur the sharpness of before and after. So we find ourselves in an interesting position. Relativity allows bending. Wormhole solutions allow loops in theory. Chronology protection suggests instability. Quantum phenomena soften our certainty about sequence. The universe is not rigid. But neither is it chaotic. It appears to allow flexibility within limits, and those limits may be precisely what keep our timeline intact. If backward travel were as easy as stepping through a doorway, history would be riddled with contradictions. Instead, history appears stubbornly consistent. The past remains fixed. The present unfolds. The future approaches but does not arrive prematurely. Perhaps that is the quiet evidence Hawking had in mind. Not proof written in symbols, but the simple absence of paradox in our lived experience. The universe may bend time gently under gravity and speed, but when it comes to looping backward, it may draw a boundary, not with force, but with fragility. A door that closes not because it is locked, but because it cannot remain open. And yet, just beyond that door, at the smallest scales of reality, something even stranger waits. Because quantum physics does not always respect the neat flow of before and after, and that subtle blurring will lead us deeper still. Up to this point, time has bent but not broken. It stretches under speed. It slows under gravity. It resists looping backward through instability. The universe appears flexible, but cautious. And then we arrive at the smaller scales of reality, where caution becomes complexity. Quantum physics does not behave like the solid world of stones and streets. It operates in a domain so small that our everyday language strains to describe it. Yet its discoveries are not speculative. They are tested in laboratories with extraordinary precision. At this scale, particles do not move like tiny billiard balls. They behave more like waves of possibility, existing in multiple potential states until measured. More importantly for our journey, the fundamental equations that describe these particles do not strongly prefer a direction of time. In everyday life, time flows one way. Ice melts, smoke disperses, coffee cools. These processes do not spontaneously reverse. This directional flow is often associated with increasing disorder, with systems naturally moving from organized to more scattered states. But the equations that govern individual particles are nearly symmetrical. If you reverse the direction of time in the mathematics, the behavior still makes sense. In simple terms, at very small scales, the laws do not care strongly whether time moves forward or backward. This does not mean that particles are travelling freely into the past. It means that the distinction between before and after is less rigid at that level. There are experiments involving entangled particles that make this even more intriguing. When two particles become entangled, their properties remain linked, even if they are separated by large distances. Measure one, and the other's state becomes defined instantly, no matter how far apart they are. This does not allow communication faster than light. It does not allow messages into the past. But it does blur our classical understanding of locality and sequence. From one perspective, it can appear as though the outcome of a measurement influences something distant without delay. In other carefully designed experiments, researchers have explored what is sometimes called delayed choice. In these setups, the way a particle behaves, whether more wave-like or more particle-like, seems to depend on how it is measured, even if that measurement decision occurs after the particle has already entered the apparatus. The interpretation of such experiments is subtle and debated. They do not imply that the future literally changes the past. Rather, they suggest that our classical picture of events unfolding in a clean sequence may be incomplete at microscopic scales. Some interpretations of quantum mechanics entertain the possibility of retrocausality, the idea that influences might not strictly adhere to forward directionality. In these views, correlations between events may extend across time in ways that do not fit our usual narrative of cause followed by effect. But it is crucial to remain grounded. These phenomena occur at scales far smaller than atoms. They do not scale easily to everyday objects. You cannot entangle a city street with a Victorian marketplace and step between them. The mathematics that describe quantum behavior are extraordinarily precise. Yet when translated into our intuitive language, they sound almost mystical. Particles that exist in superposition, correlations that transcend distance, measurements that define outcomes. It is tempting to leap from these ideas to the conclusion that time itself is fluid enough to allow spontaneous slips. But here is the gentle truth. Quantum strangeness does not easily become macroscopic strangeness. The world you walk through, buildings, streets, bodies, is composed of unimaginably many particles interacting continuously. The delicate quantum states that allow superposition and entanglement are extremely fragile. They decohere rapidly when exposed to the messy environment of everyday reality. In plain terms, the strange flexibility of quantum behavior averages out into the stable solidity we experience, and yet something profound remains. At the deepest layer we currently understand, time is not carved into stone as a rigid arrow. It is woven into equations that allow symmetry. Before and after are less sharply divided. This does not validate the story of someone stepping into 1950s Liverpool or ancient Rome, but it humbles our certainty. It reminds us that the universe is not obligated to conform to human intuition. The classical world of causes neatly preceding effects emerges from deeper principles that are stranger than we once believed. And sometimes when people report time feeling layered or blurred, they may be intuitively grappling with that deeper strangeness, even if the experience itself remains psychological rather than physical. The stories of time slips are dramatic. The physics of quantum mechanics is subtle. The two do not overlap easily, but both challenge the old image of time as a simple, unyielding line. Even if physics allows strange whispers at the smallest scales, we still inhabit a world where extraordinary claims require careful evidence. The existence of quantum symmetry does not mean the streets of modern cities occasionally revert to horse-drawn carriages, but it does mean that reality is richer and more nuanced than the clocks on our walls suggest. And so we stand at a crossroads. On one side, the mathematics of space-time bending and quantum symmetry. On the other, photographs that seem out of place, stories that circulate online and ledge travellers appearing in unexpected eras. Physics may allow subtle flexibility, but stories demand proof. And when we turn from equations to images, when we examine the photographs and viral legends that claim to capture time travellers in plain sight, the question becomes not what the universe permits, but what evidence truly shows. There is something about a photograph that feels undeniable. A story can be exaggerated, a memory can drift, but a photograph seems fixed, a captured moment preserved in silver and light. And so, when images began circulating that appeared to show modern-looking individuals standing in old historical scenes, they spread quickly. The suggestion was irresistible. What if someone from the future had been accidentally captured in the past? One of the most famous examples is often called the hipster in 1940. The image shows a crowd gathered at a public event in Canada. Everyone appears dressed, in clothing typical of the era, suits, hats, conservative styles. Except one young man, he appears to be wearing a printed t-shirt, dark sunglasses, a cardigan that seems too modern. He holds what looks like a compact camera. When the image first circulated online, many were convinced it showed a time traveller who had accidentally blended into the crowd decades before he was born. The photograph felt like proof, but when examined closely, historians pointed out that printed shirts did exist in the early 20th century. Sunglasses were not unheard of. The camera model he held was consistent with consumer devices available at the time. In other words, the anomaly dissolved under context. The image had not changed. Our interpretation of it had. Another frequently cited story involves a supposed traveller named Rudolf Fenz. According to the tale, a man dressed in 19th century clothing suddenly appeared in mid-20th century New York City, confused and disoriented. He was struck by a car. His clothing and possessions seemed authentic to the era he claimed to come from. It sounds like a classic time slip. But deeper investigation revealed that the story originated from a short science fiction piece written in the 1950s. Over time, the fictional narrative was copied into articles without attribution. It slowly transformed into urban legend. The traveller was never real. There's also the case of Andrew Carlson, a man who allegedly appeared in the early 2000s claiming to have come from the year 2256. He was said to have made impossibly accurate stock market predictions before being arrested. The story spread rapidly across online forums. Later, journalists traced it back to a satirical news website. It was fiction designed to entertain. Then there is the cell phone woman, seen in a 1928 film clip. In the footage, a woman walks past the camera appearing to hold a small rectangular object to her ear, as if speaking on a mobile phone decades before such devices existed. The image feels uncanny, but historians suggested more ordinary explanations. She may have been holding a portable radio or a hearing aid device. The gesture appears modern because we project our current habits onto it. In Spain, a carved astronaut figure on a cathedral facade was cited as proof of temporal displacement. How could a medieval building depict a spacesuited figure centuries before space travel? The answer turned out to be restoration work. During renovations in the 1990s, modern sculptors added contemporary elements as a quiet signature. The astronaut was not ancient prophecy. It was recent craftsmanship. Even a small watch allegedly discovered in a sealed ancient tomb in China was presented as evidence of misplaced time. The object bore markings resembling modern branding. But careful analysis revealed it was a miniature decorative ring shaped like a watch. It had likely been introduced during excavation. Each of these cases shares a common rhythm. An image appears unusual. Interpretation rushes in. The narrative of time travel attaches itself, and only later does careful investigation dissolve the mystery. This does not mean that photographs lie. It means that images are incomplete without context. A photograph captures light at a specific moment. It does not capture the assumptions of the viewer. We are pattern-seeking creatures. When we see someone dressed differently from those around them, we search for explanation. When that difference resembles something from our own time, the explanation may feel extraordinary. The camera feels objective, but interpretation is not. In a world saturated with digital media, anomalies spread faster than analysis. A cropped image circulates without surrounding information. A headline exaggerates uncertainty. A fictional story is repeated without citation. Repetition creates familiarity. Familiarity creates belief. And soon, what began as curiosity becomes evidence in the eyes of many. This is not new. Urban legends have always travelled through word of mouth. What is new is speed. In earlier centuries, a rumour might drift slowly between towns. Today, it crosses continents in seconds. The idea of a time traveller caught on film satisfies a deep fascination. It combines modern technology with ancient longing. The camera becomes a witness to something that should not be possible. But when examined carefully, these images consistently resolve into something more ordinary. A misinterpretation, a restoration detail, a fictional origin forgotten. And yet, the persistence of these stories tells us something meaningful. We want the crack in time to appear in plain sight. We want the evidence to slip quietly into the archive of history, waiting to be noticed. And when a photograph seems to offer that crack, we lean toward it. Not because we are naive, but because the possibility is thrilling. Still, if physics bends, quietly in quantum mechanics whisper softly at microscopic scales, photographs demand more solid ground. Extraordinary claims do not dissolve simply because they are comforting, and so, after the viral images and debunked legends, there remains one story that felt different to many. Not a blurry photograph, not an internet rumour, but a man who appeared with documents, film, and a narrative that seemed almost too detailed to dismiss. His name was Sergey Ponomarenko, and his story unfolded slowly, like a scene from another era itself. In the early 2000s, a story began circulating in Ukraine about a man who seemed to have stepped out of another era. He appeared confused, disoriented, standing in the middle of a modern street in Kiev, wearing clothing that looked as though it belonged to the late 1950s. Witnesses described him as startled by the traffic, the cars, the lights, the sounds of the city. He reportedly carried identification papers, bearing a Soviet emblem and a date that did not match the present year. His name, according to those documents, was Sergey Ponomarenko. The date on his identification suggested he was born decades earlier. Yet the man himself appeared no older than his mid-20s. When questioned, he allegedly insisted that he had left his home in 1958. He had gone out to photograph the city carrying a camera typical of that period. And then, he said, something strange had happened. He saw a bright object in the sky, a bell-shaped form suspended silently above the streets. He raised his camera. He took a photograph. And then, as he described it, everything changed. The surroundings shifted. The city looked unfamiliar. The vehicles were unlike any he recognized. The architecture seemed altered. He believed, according to the story, that only minutes had passed. But when authorities checked the calendar, nearly half a century had. It is a powerful narrative, a young man from the late 1950s suddenly arriving in the early 2000s, bewildered by the future. The story deepened. The camera he carried was examined. It appeared consistent with models produced in the 1950s. The film inside, once developed, reportedly contained photographs of Kiev as it looked decades earlier. Old buildings, familiar streets, and in one frame, a distant bell-shaped object suspended above the skyline. The details gave the story texture. It was not a vague memory. It was supported by physical props, identification papers, period clothing, a functioning camera. Authorities, according to the tale, searched historical records and discovered that a man by the same name had been reported missing in 1958. The resemblance between the missing person's photograph and the man now standing before them was striking. If this were a novel, it would be almost too perfectly constructed. But the story did not end there. After being placed under observation in a secure facility, sometimes described as a psychiatric hospital, the man reportedly vanished once again. Disappeared from a locked room, no trace. Later, according to the narrative, new film emerged. Photographs dated in the early 2000s showing Sergey again, standing beside a woman who appeared to have aged decades since 1958. In this version, time did not simply displace him once, it looped. The structure of the story mirrors some of the theoretical ideas we explored earlier. A moment of sudden transition, a mismatch between personal aging and historical time, a reappearance decades later. It feels almost aligned with closed loops in space-time, and yet, as with all compelling stories, the emotional pull must be balanced with careful inquiry. The power of the Sergey account lies in its details. A specific year, 1958, a specific location, Kyiv, a specific device, a mid-century camera. These details create a sense of solidity. When a story includes props and dates, it feels anchored. But here's where quiet examination becomes important. When journalists and researchers attempted to trace the original documentation of the case, they encountered something unexpected. The earliest appearance of the story did not originate from police records or academic reports. It traced back to a television program broadcast in Ukraine in the early 2000s. The program presented the narrative as a dramatic reenactment. Actors portrayed Sergey. Scenes were filmed to recreate the events. The tone was documentary-like, but disclaimers indicated fictionalization. Over time, segments of the reenactment were clipped and shared online without context. The line between dramatization and documentation blurred. Viewers encountered the story divorced from its original framing. The reenactment became evidence. This transformation did not occur maliciously. It unfolded gradually. One upload led to another. Comments accumulated. Details were repeated and refined. The more often the story was told, the more stable it felt. It is important to say this gently. There is no verified record of a man named Sergey Ponomarenko appearing in Kiev in 2006 with authentic documentation from 1958. There is no confirmed police file, no preserved hospital record, no physical camera archived for independent examination. What exists are fragments of a television narrative, circulated widely enough to feel real. And yet, even after understanding this, the story retains a certain gravity. Why? Because it embodies the perfect structure of a time traveller myth. An ordinary young man, a sudden anomaly, physical artifacts, a missing persons record, a mysterious disappearance. It touches every narrative desire we have explored. Proof, loop, resolution, loss. In many ways, the Sergey story is less about physics and more about storytelling. It feels convincing because it is constructed with care, and because we long for such stories to be true. We long for cracks in time to open not in abstract equations, but in the middle of familiar streets. The fact that this story dissolves under scrutiny does not make it trivial. It reveals something deeper. In the absence of verified visitors from the future, we create them. We construct narratives that mirror the bending of space-time we have glimpsed in theory. We give them names, cameras, birth dates. We allow them to wander briefly through our present. And then, as gently as they arrived, we let them vanish. The Sergey story does not prove time travel, but it proves something else. That even in an age of satellites and atomic clocks, we remain quietly fascinated by the idea that time might still surprise us. And perhaps that fascination says more about us than any missing person report ever could. If you trace the path of a modern legend, it rarely begins with certainty. It begins with ambiguity. A television reenactment filmed in a documentary style, a fictional short story published without clear attribution, a photograph shared without context, a rumour repeated in a forum where sources blur into each other. The story of Sergey Ponomarenko did not begin as an archived police file. It began as narrative media, a dramatised segment designed to evoke wonder. But once released into the world, narrative media does something curious. It detaches. Clips are uploaded. Scenes are shared independently. Translations alter phrasing, subtitles shift tone. The framing changes from reenactment to report. And slowly, something subtle happens. Repetition creates familiarity. Familiarity creates comfort. Comfort creates belief. This process is not new. Before digital networks, folklore travelled by word of mouth. A story told by candlelight became part of village memory. Over generations, details sharpened, names solidified, settings became specific. The human mind trusts repetition. If you hear something once, you question it. If you hear it 10 times from different voices, it begins to feel stable. If you encounter it in multiple languages across multiple platforms, it begins to feel verified. But repetition is not the same as evidence. In the digital age, repetition accelerates. An image posted in one corner of the internet can be copied thousands of times in hours. Each repost strips away a little context. Each retelling adds a subtle adjustment. Eventually, the story stands on its own, detached from its origin, anchored not in documentation, but in distribution. This is how the fictional account of Rudolf Fens transformed from short story into urban legend. How a satirical stock market traveller became a supposed man from the future. How a television dramatization became a documented case. The structure is consistent. Ambiguity, amplification, authority through repetition. There is something deeply human about this process. We do not simply consume stories, we collaborate with them. We refine them. We share them with slight modifications that better fit our expectations. In the case of time traveller legends, the modifications often move in the same direction. More detail, more specificity, more physical artifacts, a camera model, a hospital name, a missing person's archive. Each added detail strengthens plausibility, and plausibility feels like proof. But proof in science requires something different. It requires independent verification, documentation that predates the telling, physical evidence accessible to examination. Time traveler legends consistently lack this layer, and yet they persist. Why? Because they speak to something deeper than fact. They speak to longing, the longing to step outside chronology, the longing to revisit mistakes, the longing to see what lies ahead, the longing to believe that time is not a locked corridor, but a hallway with hidden doors. In this sense, the evolution of a legend mirrors the evolution of memory itself. Details, reinforced through repetition. Emotional resonance strengthens retention. Ambiguity allows flexibility. A good story survives because it satisfies. The Sergey narrative satisfied. It combined Cold War imagery with modern technology. It included physical artifacts and institutional authority. It offered a loop, a disappearance, a trace of something unexplainable. It was constructed with narrative elegance, but the elegance belongs to storytelling, not space-time. And recognizing this does not diminish the wonder of the universe. It clarifies where that wonder truly resides, not in viral clips, not in unsourced photographs, but in the deeper questions that gave rise to them. When a legend forms, it reveals what a culture hopes might be possible. In earlier centuries, people told stories of travelers stepping into fairy realms where time flowed differently. A night in the forest became a century in the village. A brief dance with mysterious beings resulted in decades passing unnoticed. These tales were not concerned with physics, they were concerned with mortality, with the fear that life moves too quickly, with the ache of lost time. Modern time traveler legends wear contemporary clothing. They carry cameras and stock portfolios, but the emotional core remains the same. We want time to behave differently. We want the door to open. We want proof that the past is not sealed and the future not distant. When stories circulate claiming such proof, they attract attention not because they are convincing in a forensic sense, but because they resonate. The camera feels objective. The reenactment feels documentary. The repetition feels validating. But belief built on repetition is fragile. It dissolves under careful light. And when it dissolves, what remains is not emptiness. What remains is the deeper question. Why do we need time to break? Why does the idea of stepping outside chronology feel so compelling? To answer that, we must turn away from viral footage and return to something quieter, the one-way nature of time itself. Because beneath every time slip story and every traveller legend lies a simple truth. Time moves forward, moments pass, ice melts, smoke disperses, and we do not get them back. The stories attempt to soften that reality. But before we explore that longing, we must first understand the direction of time as physics describes it, not at the scale of quantum particles, not at the scale of wormholes, but at the scale of everyday life, where coffee cools, where footprints fade, where yesterday does not return. There is something quietly undeniable about a melting ice cube. Place it in a glass of water and wait. Slowly its sharp edges soften. The cube shrinks. The water cools. The structure that once held firm dissolves into the surrounding liquid. You do not expect the process to reverse. You do not expect the water to spontaneously gather itself, reform crystalline edges, and rise neatly back into a cube. Smoke behaves the same way. Once it leaves the flame, it drifts outward, thinning into the air. It does not return to the wick and reconstruct the candle. These are simple observations, ordinary, familiar, and yet they point to one of the deepest features of our universe. Time moves in one direction. Physicists often describe this as the arrow of time, not a literal arrow, but a metaphor for directionality. The idea that events unfold from ordered states into less ordered ones. There is a concept in physics called entropy, which refers to the number of ways a system can be arranged internally. In everyday language, it is often associated with disorder. When ice melts, the molecules that were once locked into a tidy lattice spread into more random motion. When smoke disperses, the concentrated particles spread outward into countless configurations. The universe seems to favour this spreading. It moves from concentrated and structured states toward more dispersed and mixed ones. This tendency gives time its direction. If you were to watch a video of smoke gathering back into a candle flame, you would immediately sense something wrong. Your intuition would reject it because it violates this natural progression. The equations governing microscopic particles may be largely symmetrical in time, but when billions upon billions of particles interact, the overwhelming statistical tendency is toward increasing entropy. Order into disorder, structure into diffusion. This statistical directionality is what makes the past distinct from the future. You remember yesterday because it was a lower entropy arrangement of events leading to now. You do not remember tomorrow because it has not yet unfolded from the present state. The irreversibility of time is not imposed from outside. It emerges from probability. There are simply far more ways for a system to be mixed than to be neatly arranged. And so, the universe drifts gently in that direction. This drift is not dramatic. It is constant. Coffee cools because heat spreads from concentrated regions into cooler surroundings. Ink dropped in water disperses because there are vastly more ways for it to be evenly mixed than to remain confined. These processes define our experience of time. And this is why backward time travel feels so powerful as an idea, because it promises escape from irreversibility. It promises that melted ice might reassemble, that dispersed smoke might return, that mistakes might be undone. Every time Slip Story carries this emotional undercurrent. Even if the narrative does not explicitly involve regret, it whispers of return, of stepping back into a previous moment, of encountering the past not as memory, but as presence. But the arrow of time is not easily bent backward. To reverse entropy on a large scale would require an almost impossibly precise rearrangement of countless particles. It would not simply mean walking into a different year, it would mean reconstructing an entire state of the universe. Every molecule in the air, every photon of light, every neuron in every brain. The scale of coordination required is staggering, and so, while relativity allows time to stretch, and quantum mechanics softens our certainty about sequence at tiny scales, the macroscopic arrow remains firm. Ice melts, smoke disperses, stars exhaust their fuel, we age. Time slips, as folklore presents them, bypass this arrow. They suggest that one individual can step backward without altering the larger progression. But if the arrow of time is statistical and universal, such local reversals would require extraordinary isolation from the surrounding environment. The traveller would need to detach from the entire web of entropy. This is not something our current understanding of physics supports, and yet, emotionally, the longing persists. Because irreversibility is difficult to accept. We lose moments, we lose people, we lose opportunities. Time does not pause for reflection. It does not offer rehearsals. This is why stories of temporal displacement resonate so deeply. They push against the one-way flow. They imagine cracks in the arrow, but perhaps the real mystery is not whether the arrow can break. Perhaps it is why it feels so heavy. Why the awareness of passing time carries such weight. The arrow of time is not malicious, it is simply statistical inevitability. And yet, within that inevitability we find meaning. because if moments cannot be replayed, they matter. If yesterday cannot return, today becomes precious. Time slips promise return. Physics suggests progression. Between those two poles lies the human experience. We live within a universe that moves forward relentlessly, yet we carry minds capable of revisiting the past in memory and projecting into the future in imagination. In that sense, we are already travellers, not through space-time in the dramatic sense, but through possibility, and perhaps the tension between irreversible physics and flexible imagination is where the true mystery resides, because even if time refuses to reverse, we continue to dream of doing so, and that dream reveals something profound about us. If the arrow of time feels firm, ice melting, smoke dispersing, moments slipping away, there is another perspective in physics that complicates this certainty in a quieter way. It begins not with entropy, but with relativity. When Einstein described space and time as woven together into a single fabric, he replaced the idea of separate ticking clocks with something more unified. Events are located not just in space, but in space-time. Each moment has coordinates, where and when. In this picture, the universe can be imagined as a vast four-dimensional structure. 3 dimensions of space, 1 dimension of time, together forming something like a landscape. Now imagine that this landscape is not being created as you move through it. Imagine instead that it already exists in its entirety. Every event, past, present, future, occupies a fixed location within this structure. You're not watching time unfold like pages being written. You're moving through pages that already exist. This view is sometimes called the block universe. The metaphor is gentle. Picture a reel of film. Each frame is complete. The entire story exists along the strip. When projected, the frames appear to move, characters act, scenes change, but the reel itself is static. Or imagine a map that includes every road, every intersection. When you drive, you experience one stretch at a time, but the map contains the whole journey simultaneously. In this view, what we call the present is simply the slice of space-time our consciousness is currently experiencing. The past is not erased. The future is not unborn. They are simply located at different coordinates. This idea arises naturally from relativity's treatment of simultaneity, because there is no universal present. 2 observers moving at different speeds may disagree about which distant events are happening now. If there were a single global present moment, such disagreement would not be possible. Instead, what counts as now depends on perspective. If the present is relative, then the separation between past and future may not be absolute in the way we intuitively assume. From within the block universe perspective, time does not flow. We flow. Our consciousness moves along a world line, a path through space-time, experiencing one coordinate after another. This idea can feel unsettling. It suggests that tomorrow may already exist in the same way yesterday exists, that events we think of as not yet determined may already be embedded in the structure. But it is important to remain careful here. The block universe does not imply that we can freely jump to other coordinates. It describes the structure of space-time, not the mobility of consciousness. Even if all moments exist within the 4-dimensional geometry, there is no known mechanism that allows an observer to detach from their world line and step sideways into a different one. The metaphor of a film reel is helpful, but limited. Characters inside a film do not leap into other frames at will. Still, the perspective changes something subtle. If the past is not destroyed but simply located elsewhere in the structure, then time travel might not be about reconstructing what has been lost. It might be about accessing a different region of the same whole. The difficulty, of course, lies in access. The laws of physics describe how objects move forward along their paths. They do not provide a method for reversing direction or skipping segments. the arrow of entropy still applies within the block. Even if the structure is complete, the statistical direction of processes within it remains forward. And yet, philosophically, the idea carries weight. It reframes the longing embedded in time slip stories. Perhaps what people intuitively sense when they imagine stepping into another era is not the destruction of the arrow, but the coexistence of layers. The present feels thin because we experience only one slice of a larger whole. If the block universe is even partially accurate, then the past is not gone in an absolute sense. It is simply inaccessible, like a room sealed behind a wall. This does not make time slips physically plausible in city streets, but it does soften the boundary between real and no longer. In everyday life, we treat the past as vanished. We speak of it as though it has dissolved into nothingness. The block perspective suggests otherwise. It suggests that events are fixed within space-time, not erased, and that what we experience as flow may be a feature of consciousness rather than a feature of the universe itself. This distinction is profound. It implies that time travel, if it were ever possible, would not require rebuilding the past from scattered entropy. It would require navigating the geometry of space-time. But again, geometry alone does not grant mobility. We return to the same boundary. Structure does not imply access. The block universe invites awe. It expands imagination. It challenges the idea of a fleeting present, but it does not provide a hidden door in the wall. And yet, emotionally, it satisfies something. It reassures us that the past is not annihilated, that moments once lived still exist somewhere in the architecture of reality. We cannot step back into them, but perhaps they are not entirely lost. This perspective does not validate the hipster in 1940 or the man from 1958. It does not confirm Bold Street as a portal, but it reminds us that time, even when irreversible, may be more layered than it appears. And sometimes, when people describe feeling that layers overlap, they may be expressing something intuitively aligned with this deeper geometry. Not literal travel, but an awareness that the present is part of something far larger. Vast structure in which every moment has its place, and perhaps, for tonight, that is enough. If time rarely breaks in physics, it bends easily in memory. Close your eyes for a moment and think of a place from years ago, a childhood bedroom, a schoolyard, a kitchen filled with a particular scent. The scene appears almost instantly. The light has a tone. The air feels textured. Voices echo faintly. You are not physically there, but something in you has travelled. Memory allows you to revisit moments without reconstructing every particle in the universe. It bypasses entropy in a very specific way. It does not reverse melted ice. It doesn't gather smoke. It reconstructs patterns within the mind. This ability is astonishing, and it may be one of the reasons we're so drawn to literal time travel stories, because emotionally we already experience something similar. We return to conversations in our thoughts, we replay mistakes, we imagine alternative responses, we rehearse different outcomes. Regret is a form of mental time travel. Nostalgia is another. Hope, too, is temporal movement. It projects forward into a future that does not yet exist for us experientially. The mind moves along timelines fluidly. The body does not. This separation creates tension. We are creatures aware of time. Other animals respond to change. They remember in certain ways. But human consciousness appears uniquely preoccupied with chronology. We track birthdays. We mark anniversaries. We anticipate deadlines. We measure age. We know we are moving toward an endpoint. Mortality sharpens our awareness of irreversibility. Every passing year feels both ordinary and profound. Ordinary because days resemble one another. Profound because they accumulate. When time feels heavy, stories of time slips feel light. They suggest that chronology is not absolute, that perhaps mistakes can be undone, that perhaps loss is not final, that perhaps the boundary between before and after is porous. This desire does not require gullibility. It requires vulnerability. Imagine someone who lost a loved one unexpectedly. The idea of stepping back for even 5 minutes to say something left unsaid is emotionally overwhelming. Or imagine someone burdened by a decision that altered the course of their life. The thought of revisiting that moment carries both dread and longing. Time travel, in this sense, is not about curiosity. It is about control. Control over sequence. Control over consequence. Physics offers no such control. Entropy moves forward. World lines extend in one direction. The block universe does not permit detours, but psychologically, we rehearse detours constantly. We reconstruct alternate versions of ourselves in our imagination. What if I had chosen differently? What if I had spoken sooner? What if I had waited? These questions do not change the past, but they reveal how deeply we experience time as a boundary between possibility and permanence. Time. Slips in folklore often occur unexpectedly. A person turns a corner and finds themselves in another era. They observe briefly, then they return. Notice how these stories avoid permanence. The traveller does not become trapped irreversibly. They're given a glimpse, a visit, a temporary suspension of chronology. This mirrors our inner experience. Memory allows a visit, imagination allows a preview, but we return to the present because we must. Perhaps the fascination with time travellers caught on film is less about proof and more about reassurance. Reassurance that time is not as rigid as it feels. Reassurance that beneath the arrow of entropy lies something softer. And yet, the softness exists primarily in consciousness. The brain itself is a temporal organ. It does not simply record events, it predicts them. It constructs continuity. It stitches together past and future into a coherent narrative called identity. Your sense of self depends on temporal continuity. You remember being younger. You anticipate being older. You maintain a thread across years. If time were to fracture unpredictably, identity would fracture with it. So while we dream of time bending, we also rely on its stability. There is a delicate balance here. We want flexibility without chaos. We want the possibility of return without the collapse of causality. We want cracks in the wall, but not the destruction of the house. This tension may explain why time travel stories often follow a pattern. The traveller glimpses another era but does not rewrite history. The past appears intact. The present resumes. The arrow remains largely unbroken. Because psychologically, we do not truly want chaos. We want meaning. Meaning requires sequence. Events build upon one another. Consequences shape identity. Loss defines attachment. Achievement defines growth. If time were endlessly reversible, meaning would dissolve. Every mistake could be erased. Every consequence undone. Urgency would fade. The very weight that makes moments precious would disappear. So perhaps our longing for time to break is paired with an equal longing for it to hold. We tell stories of time slips not to dismantle chronology, but to play gently at its edges, to imagine what lies beyond the boundary without tearing it down. And in doing so, we reveal something essential. Time travel is not only a physical question, it is a psychological metaphor, a reflection of our struggle with irreversibility, a mirror held up to mortality. And perhaps, when we look at it closely, we see not cracks in space-time, but cracks in our acceptance. Acceptance that moments pass. Acceptance that decisions cannot be undone. Acceptance that life moves forward, even when memory moves backward. And that acceptance, quiet and difficult, may be the deepest journey of all. We began with a simple but unsettling question. Are time slips real? Do people truly step across invisible thresholds into other centuries? Do mysterious travellers wander briefly through eras that are not their own? We have walked through crowded streets where history seemed to flicker. We have examined photographs that felt out of place. We have followed a man from 1958 into a future he claimed not to recognise, and each time, under careful light, the physical evidence dissolved. Stories grew from fiction. Images revealed context. Records traced back to reenactments. If we stop here, the answer seems straightforward. No verified case demonstrates literal transportation across time. There is no documented instance of someone stepping outside their century in a way that withstands scientific scrutiny. And yet, to stop there would feel incomplete. Because along the way, we uncovered something more subtle. Time bends in physics. Clocks tick differently depending on speed and gravity. The universe does not share a single universal present. Space-time curves. Under extreme conditions, equations hint at loops and bridges. At the smallest scales, quantum mechanics softens the sharp boundary between before and after. The arrow of time emerges statistically, not fundamentally, from the overwhelming probability of increasing disorder. Time is not the rigid, absolute river once imagined. It is flexible in structure, but it remains consistent in experience. We also discovered that the mind itself is elastic. Memory revisits the past. Imagination anticipates the future. Regret rehearses alternative outcomes. Nostalgia restores vanished rooms. We already live as psychological time travellers. We slip between moments constantly, not through portals in space-time, but through the architecture of consciousness. And perhaps this is where the deepest cracks in the illusion reside. Not cracks in the fabric of the universe, but cracks in the assumption that time is singular and simple. We tend to imagine time as a straight line extending infinitely in both directions. But physics reveals curvature, psychology reveals layering, narrative reveals longing. The illusion is not that time slips are real. The illusion is that time is uncomplicated. It is not. It is geometry and probability. It is memory and expectation. It is entropy and identity. It is both structure and story. When someone turns a corner on Bold Street and feels displaced, perhaps they are encountering the fragility of perception. When a photograph appears to show a modern figure in an old crowd, perhaps we are encountering the fragility of interpretation. When a man claims to have stepped from 1958 into 2006, perhaps we are encountering the fragility of narrative boundaries in the digital age. None of these require literal fractures in space-time. They require only the subtle complexity of mind and culture. And yet, even knowing this, the question lingers softly. Could there be aspects of time we still do not understand? The honest answer is yes. Science is not complete. Our models evolve. What once seemed impossible sometimes becomes measurable. But extraordinary possibilities require extraordinary evidence. So far, time slips remain within the realm of story. But stories are not meaningless. They reveal the contours of our desire. We want more time. We want second chances. We want reassurance that moments are not irrevocably lost. We want to believe that somewhere, behind the arrow and beneath the entropy, there is softness. Physics gives us subtle bending. Psychology gives us fluid memory. Myth gives us travellers. Together they create a tapestry in which the idea of stepping outside time feels almost plausible. But plausibility is not proof. So where does that leave us? It leaves us here, in a universe where time moves forward statistically and bends geometrically, in a mind that moves freely through recollection and imagination, in a culture that amplifies anomaly into legend, and in a present moment that is both fleeting and profound. Whether or not anyone has ever stepped outside, their century we are all travellers, not through wormholes or folded pages of space-time, but through a dimension we barely understand. Every second carries us forward along our world line. Every memory carries us backward in reflection. Every hope carries us forward in projection. We stand between what has been and what will be, anchored in what is, and perhaps that is mysterious enough. Time slips may not open doorways in city streets, but the fact that time bends under gravity, softens under quantum symmetry, and stretches in memory is already extraordinary. The illusion is not that time sometimes breaks. The illusion is that time is simple. It is not. It is layered. It is structured. It is fragile in perception and firm in progression. And as you rest tonight, consider this quiet truth. You're moving through a four-dimensional landscape at a steady pace. You cannot reverse direction. You cannot leap ahead. But you're part of something vast and intricate. And that alone is wonder. Not because time breaks, but because it exists at all.